Hello friends, welcome to the channel solution. In this video we will show you how to separate and identify unknown amino acid by paper chromatography. Here we have used Whatman filter paper number 1. You can also use normal filter paper for this purpose. Cut the filter paper into a strip of rectangular shape. Here we have prepared 3 sample solution of amino acid of volume 10 ml each. Solution A and the solution B is the standard solution of amino acid leucine and valine of concentration 1 mg per ml in distilled water. Third solution is the sample mixture of amino acid which we have prepared for the demonstration purpose of separation by paper chromatography by mixing small volume of solution A and the solution B. Draw a starting line of about 1.5 cm from the bottom of filter paper by the pencil. Draw another line as the end line at the top of filter paper, and this is the line up to which we allow the mobile phase to move. Mark the 3 points by the pencil on the starting line of equally spaced on which we apply the spot of the sample solution. Dip the narrow end of the capillary tube to draw small volume of the standard solution A. Touch the capillary tube gently to the paper to transfer very small volume of the sample on the mark point at one end of the starting line. Again apply the spot of standard solution B in the similar way on the mark point on the starting line using another capillary tube. Again apply the third spot of sample mixture solution of amino acid on the third mark point of the starting line. You can also label each spot below the starting line for its identification. We have a staple thread on the top of the filter paper to hold and support the filter paper in the upright position at the center of the beaker at the time of development. Meanwhile, we have prepared 10 ml mobile phase by mixing N-butanol, glycyl acetic acid and water in the ratio 4:1:5 and then allowed the beaker to saturate with the mobile phase vapor. Immerse the filter paper vertically in the center of the beaker. Note that the level of mobile phase in the beaker should be such that the spot should not dip into the solvent. Cover the beaker with the petri dish and then allow the mobile phase to move over the filter paper up to the end line through the capillary action. Paper chromatography is based on the principle of partition. Here the component of mixture partition between the two liquid phase. One is the stationary phase, which is the water held in the pore of filter paper, and second is the mobile phase. The component in the mixture gets separated due to the difference in the affinity of the component towards the stationary phase and the mobile phase. When the solvent touches the end line, which is at the top of the filter paper, take out the paper from the beaker and mark the solvent front with the pencil, and then allow the filter paper to dry at room temperature. You can see that the spots of amino acids are not visible. So after drying of the filter paper at the room temperature, spray the filter paper with neon hydrogen reagent to detect the spots of amino acids. Spray the filter paper with the neon hydrogen reagent, and after spraying, dry the filter paper in hot air oven at 100 degrees Celsius for about 5 to 10 minutes. Neon hydrogen react with the amino acids to give bluish violet color. After drying in the hot air oven, you can see the bluish violet spot of amino acids. After this, outline each spot of amino acids on the filter paper by the pencil and mark the center of each spot. After outlining each spot of the amino acid and marking the center of each spot, measure and record the distance of each spot from the starting line to the center of each spot. Also measure the distance run by the solvent from the starting line and then calculate the RF value of each spot. RF value means the retention factor and is calculated by dividing the distance travelled by the individual component from the origin divided by the distance travelled by the solvent. Here we have calculated RF value of spot 1 of standard solution A. Similarly, you can calculate RF value of spot 2 of standard solution B and the RF value of two spots A and B obtained after the separation of mixture sample solution. After the calculation of RF value of each spot, then identify the amino acids of the mixture by comparing the RF value with that of the standard solution. Here the spot A is spot of leucine and B is the spot of valine. Thank you for watching this video.